Alright guys, welcome to week 9 review help video. Let's go ahead and get started here. Number 1, we've got a chain rule situation on our hands. There's a lot going on here. There's actually, I don't think I've done one like this before. We've done a double chain rule, but this is actually going to end up being a triple chain rule. So we have this function, which is the outermost function, the ln, and then we have an absolute value function after that. And then after that, we have a sine function. And then after that, we have the 4 over x squared function there on the very inside. So there's a lot there. And basically, we just got to take the derivative of each one and multiply them all together. So when it comes to the ln, when you take the derivative of an ln, you just do 1 over whatever is inside the ln, and in this case that's this. Next we have the absolute value, and when you take the derivative of an absolute value function, you just basically put everything that's inside the absolute value on the top of a fraction, and everything, and you just rewrite the entire absolute value underneath of it like this. Then we have the sine function there, and the sine function, the derivative of sine is cosine. And then finally we have the innermost function there, which I'll show my work on the side here a little bit to do that one. First of all, you want to rewrite it where the x squared is up at the top with a negative exponent. Then you do the power rule, where you multiply it to the front and you subtract 1 from the power. And then we rewrite it again to where the x cubed goes on the bottom and with a positive 3 now. So we now have negative 8 over x cubed. All right, and then we want to go ahead and just put all this together now. So let's go ahead and do that. So in the top of our fraction, we have this, this, and this. So I'm going to go ahead and put those in there like this. So that'd be 4 over x squared, and then cosine 4 over x squared, like so. On the bottom, we have this, and this, and this. Now the first two are actually identical, which means that you can really just write it as a square. Now, I don't know if this is going to happen on your guys' problem, but for mine, I think that we can simplify this a little bit. When you square something, it's automatically positive anyway, right? So we don't really need these absolute value bars anymore since it's being squared. So I'm going to go ahead and get rid of that. And now since those absolute value bars aren't there, I can actually reduce this with one of these down here, which cancels that out and leaves me with just a regular old sign there on the bottom. And I can have a simplified one. Now, like I said, I don't know if that's going to happen on the one you guys have on your video. Off the top of my head, I can't remember. But I'm just thinking if you got an absolute value that's being squared, you don't really need the absolute value anymore. And because of that, I'm able to reduce it. But here's how I would write my final answer on this guy here. All right. But anyway, all that being said, basically it's a big old chain rule problem. We have a lot of inner and outer functions to multiply it all together, and then I just simplify it at the end. So let's go ahead and take a look at an example for number 3. I'm not doing an example for number 2. That's either because it's already like number 1, or I figure it's kind of simple enough to where you don't need an example. So we're going to jump on into number 3 here. So find y prime of this function here. All right, so notice that we have an implicit function. So when you have an implicit function, we start off like this. And if you forgot what an implicit function is, that's a function where the y is not by itself. It's all wrapped up inside of the expression. All right, so let's go ahead and get to business here. So first of all, I'm going to take the derivative of that. That's 4. Take the derivative of that, that's 0. Then we take the derivative of this guy. Now this is going to be a chain rule situation. So I have an outside function, which is the ln there. And then I have the inside function, which is a y squared minus 4x. So let's go ahead and start off by taking the derivative of the ln. The derivative of ln is always 1 over the inside. So that's nice and smooth there. No problems there. Next, we got to do the derivative of the inside. Now, when I take the derivative of this, I get 2y. But since it's a y, I also get a y prime, right? Minus the derivative of that is 4. And then I'm going to go ahead and just put all this together here. Change it all back to black, though, now, so that I... All right, so now the goal here is I want to find out what y prime is, right? And so I need to get this y prime right here by itself. Now the first thing I would do to get y prime by itself is I would multiply the denominator on both sides. So I'm going to multiply this side by y squared minus 4x, and I'm going to multiply this side by y squared minus 4x. That way these cancel out. And so now I've got y squared minus 4x being multiplied by a 4 is now equal to 2y, y prime, minus 4. All right, the next thing I would do is I would go ahead and add this 4 on both sides. So now I've got 4 y squared minus 4x plus 4 is equal to 2y, y prime. And the last thing I would do is I would go ahead and divide both sides by 2y. And that gets the y prime by itself. Now we might be able to simplify, and once again, I don't know if they're going to be expecting any kind of simplification on your problem that you're doing exactly, but in this case, I see that I can divide this 2 into this 4 and this 4, and as a result we can have a reduced expression there. So if I were to rewrite it in simplified form, then I would just have a y on the bottom, and instead of 4's there I would have 2's. Okay? And that'll do it. So that takes care of number 3. Let's go ahead and take a look at an example for number 4. So they give me a function here and they ask me what's the value of f prime of 1. So to do that, the first thing we gotta do is find what f prime of x is by taking the derivative. So if I take the derivative of that, I'm just going to get 6x, right? You multiply the power to the front and take 1 off of the power. Next we have this guy. That 9 is going to stay right where it is. Also, the derivative of the e is going to stay exactly the same, because when you take the derivative of an e function, it stays the same. But we will be multiplying it by the derivative of the exponent, which is like your inside function. So we're going to put a times 2 there. And that 2 and the 9 can go together there. So if I were to simplify that, I would have 6x plus 18 e to the 2x minus 1. And now we're ready to go ahead and plug in our value of 1 here. So let's do that. Oops, don't want a parenthesis there. So that's 6 plus 18e. 2 times 1 is 2, take away 1 is 1, so I have e to the first power, and that's about as simple as that problem's going to get right there. So that's the end of that one. Let's go ahead and take a look at number 6. Once again, I'm skipping 5, either because number 5 is like number 4 or because it was easy enough to where you shouldn't need an example at this point. Let's go ahead and take a look at number 6, though. Y equals this, and I want to find the derivative. All right, this is a product rule. We have 5x squared is one thing, and then the tangent of x is another thing. And when we learned this, I called this guy the A. I'm going to go back to using black here. This is the A and this is the B. And the rule for the product rule is you do A times B, where on the first set the A is prime and on the second set the B is prime. Here we go. So we have A prime, which is going to be the derivative of 5x squared, that's 10x. And then we have tan x, which goes here. And then we have A, which is 5x squared. And then B prime, the derivative of tangent is secant squared x. And that's probably going to be good enough for this problem. So if you were to write it out without all the extra bells and whistles on there, it looks something like this. Now what's important to understand is that on these, they might have put this one, well, these two things are interchangeable. So they could have had them swapped places. That's totally fine. Just because with plus, addition is commutative, so it doesn't matter what order they're in. But other than that, I think you should be able to find an answer that matches yours. So let's go ahead and take a look at number 7. Another one where we're being asked to find the derivative where we plug in 0. We did that earlier, but this time it's got a product rule, and I think we struggle with product rule a little bit sometimes, so thought I'd help you. This one also has a chain rule inside of it, I see. So we have, here's my A and here's my B. So we have AB, AB, and that's going to give me my derivative. So that's the first thing we've got to do, is we've got to find our derivative. After we find our derivative, we can go ahead and plug in the value that they gave us, which is 0, but that's the last step. So let's do the derivatives first. So how do I find the derivative of this thing? Well, this is actually going to be a chain rule. We have an outside function here. It's the third power. And then we have our inside function, which is the 3x to plus 4. So let's go ahead and start off with the derivative of the outside function there. The derivative of the outside, we're going to move the 3 to the front. So we end up with 3 parentheses. Then we take 1 off the power and keep the inside the same. And then we multiply it by the derivative of the inside. The derivative of the inside is just 3. So there's that. Now we're going to move on to the derivative, or the next one, which is b. b is just e to the x, so that's easy enough. Next we have a, which is right here, so I'll just write that again. And then we have b prime. Now the derivative of e to the x is still e to the x. That doesn't change. So in this case, b is the same thing as b prime. All right, so I think we can go ahead and simplify this a little bit here. Not really horribly necessary, but I guess I will. Okay, so now we're ready to go ahead and plug 0 in. So I'm going to go through and I'm going to replace all these x's here with 0. Plug 0 in there, plug 0 in there, here, and here, and let's see what we get. All right, so 3 times 0 is 0, plus 4 is 4. 4 squared is 16. And 16 times 9, it's a big number. I don't think I can do that yet. Let me wait on that. E to the 0 is 1, so we can just put a 1 there. Here we have 3 times 0 is 0, plus 4 is 4. To the third power, I believe that is 64, if I'm not mistaken. And then we have e to the 0, which is 1. Okay, let's do this 9 times 16. What is that? 90 and 54. So I think that's 144. And then 64. And then putting these together, we have 8. 208, it looks like. All right, so that would be my final answer. So basically, I did the product rule, and then I plugged in my number, which gave me 208, final answer. That's a pretty steep slope. All right, number 8. What is the slope of the line tangent to this function? Well, if you want to find the slope of a line that's tangent to your function over here, you got to find the derivative. So the first thing we're going to do is we're going to find the derivative of this function. And as you guys can see, this is going to be a quotient rule. And the chain rule is going to make a little appearance as well. So with the quotient rule, it's low, d high, minus high, d low, draw a line, square below. So low is 4x plus 1. D high, that's an interesting one. So I want to find the derivative of this top function now. And that's going to be a chain rule. The e is the outside function, so that's going to stay the same. E to the negative 2x. But we do want to multiply it by the derivative of the inside, which is the exponent itself, so that would be negative 2. So that's a chain rule there inside of the quotient rule. All right, so we have low d high minus high d low. And then we square below. Now we could go through the trouble of simplifying this, but it's not really necessary if we're going to be plugging a number in, because we can just simplify after we got the number and it's a little bit easier. So let's go ahead and plug in our number. Okay, so let's start here. That's going to be 9. This guy here, we're going to have negative 2 e to the negative 4. And we're going to have e to the negative 4. And then on the bottom, we're going to have 9 squared, which is 81. So there's that. All right, so now it's possible that they'll just have that as an answer. I don't know, maybe you guys will get lucky and that's where it'll be good enough. But technically, we could do some algebra with this thing a little bit. So first thing I want to draw you guys' attention to is the fact that both this term and this term have an e to the negative 4. So what I'm going to do is I'm going to factor that out. But actually, before I do that, let's multiply these together. So that's going to be negative 18 e to the negative 4 minus 4e to the negative 4 all over 81. And you know, as a matter of fact, instead of factoring, I think we could just combine these together, right? I've just got two expressions with an e to the negative 4. So I could just combine their coefficients. Negative 18 and negative 4 makes negative 22 e to the negative 4. And we don't typically like negative exponents, do we? So what we could do is we could just move that to the bottom. So this would be the simplest answer. Maybe you would want to see if you can reduce if possible, but nothing reduces here for me, so I'm done. But once again, I'm not too sure on the College Board example that you're going to be doing. Will it be okay just to stop here? I don't know. Take a look. If you don't see that answer, then keep going. You might be able to combine and move that thing to the bottom like I did. But anyway, let's go ahead and move on to number 9 here. So this is another example. It's asking the same thing. It just gave us a different function this time. So just get to practice our derivatives a little bit. So once again, we start by finding the derivative. So that's going to be 1 over 8 minus x squared times 2x, or negative 2x. Why? Because this is a chain rule. The outside is an ln, and when you take the derivative of an ln, you just get 1 over the part that's inside the ln, and then the derivative of the inside is negative 2x. So just putting those together, then we have negative 2x over 8 minus x squared. Now they want me to find the value of the derivative at 2, because that would give me the slope of the tangent line. So I'm going to plug in 2 now. Which is going to give me negative 4 over 8 minus 4, which is negative 4 over 4, which is negative 1. So find the derivative, plug in the number, good to go. All right, and that'll do it for our examples for today. So hopefully that was helpful, and we'll see you guys later.